Okay, so this webinar is on manufacturing and artificial intelligence with a special focus on predicting downtime on your equipment in your manufacturing facility. My name is Jared Evans. I'm a co-founder of MAJiK Systems. We make production monitoring and factory analytics software that connects directly to equipment in your plant. I'm also on the MT Connect technical advisory group for the MT Connect data protocol, as well as our company is a founding startup member of the Advanced Manufacturing and also Scale AI Supercluster initiatives in Canada. Previously, I've worked at Apple as a hardware engineer and also program management at Broadcom. So I just want to give a little bit of an overview of what MAJiK Systems does. So we connect directly to production equipment on the plant floor. We have support for 90% of legacy PLC and SCADA systems in the market. Do that through a nice, easy drag and drop integration. Pull that into our databases on premise. Give you all kinds of reporting for monitoring, analyzing, and optimizing your equipment, as well as providing that data out to other third-party systems like your ERP system, maintenance management systems like Fix, and also up to Microsoft Azure through the Azure IoT Hub if you're wanting to do more cross-site comparison, high-level predictive maintenance, things like that. We work with some great manufacturers, and were recognized last year as a top 10 MES provider by Manufacturing Technology Insights magazine. A lot of our customers are some of them are just beginning their digital manufacturing journey. Some of them are fully bought in and seeing huge results. And it's very exciting to work with all of them and see them sort of leading the pack within manufacturing today. So I'm hoping that you'll have a few takeaways from this talk. First, I want to give you enough knowledge to be dangerous on where can predictive maintenance be most effective in your plant, and then also for pitfalls that you should be watching out for when you're trying to do software-based predictive maintenance. Also want to talk about a case study of where we have done predictive maintenance work this past year, and then also discuss opportunities for automotive manufacturers especially, but also all manufacturers to be able to take advantage of different grants that governments are offering to get started on your journey. So first I want to talk quickly about Industry 4.0 though, because Industry 4.0 and artificial intelligence and IIoT, Industrial Internet of Things, all of these terms tend, especially at conferences and demo days for industries, tend to start getting jumbled around and used interchangeably and things like that. And I just want to make sure that we're sort of focusing on our different areas and everybody sort of understands from the start on the same page what I mean when I'm using certain different terminology. So Industry 4.0 refers to the fourth industrial revolution, and the idea behind it is that you're connecting everything in your factory from your largest automation equipment, your ERP system, right down to your smallest systems like even safety buttons, even worker tracking, that type of thing. And from doing that, you're going to be generating massive amounts of data that allow you to put analytics to work and run your factory more efficiently, have smaller batch sizes, grow your product flexibility, and all kinds of other great promises. Really what it boils down to, though, is ubiquitous computing across the plant floor, of which one part is artificial intelligence. Now, just to take a step back, the BDC did a great study last year on Canadian manufacturers and how they're doing with adopting Industry 4.0. 39% of Canadian small and mid-sized manufacturers have implemented some sort of Industry 4.0 project. But when you look at the breakdown, actually only 3% are fully implemented. And I would count most of our customers in that fully implemented area, where They're connecting all of their production machines in a plant. They're able to see in real time what's going on, get notifications for downtime and other issues, and know whether they're going to hit their production schedule or not. Canada is lagging behind the rest of the world, I would say, in terms of uh, where we're at with implementations. We have a little bit of a follower mentality. Um, the BDC study also found that the biggest challenges for implementing Industry 4.0 solutions were lack of qualified employees and then also excessive costs, or I would also lump that in with unclear return on investment. So today, I definitely want to sort of help you in two areas with that if you're looking at an Industry 4.0 or artificial intelligence trial or next step. Is I want to provide you with some more information so you know how to judge the qualifications of employees and contractors and partners that you're working with, as well as deal with, hopefully I can give you at the end some help with the excessive costs as well, talking about some really new exciting grants that are coming up. And you will need to look at grants that are available probably, especially if you're doing a pilot project. The BDC study again found that the average investment in Industry 4.0 over the last 2 years for clients that were being successful was around $260,000. That does sound like a big price tag, but again, remember that's for all Industry 4.0 projects at a certain facility, not specifically to predictive maintenance, that type of thing. Um, so that's including employee costs for new focus groups, hardware for getting data off of the plant floor, as well as consulting, all kinds of things, right? So there's many ways to cut down on those costs or offset those costs. But at the same time, I would say that even if you are paying full price for this type of innovation, the benefits of adopting digital technologies and predictive maintenance and things like that are huge. Being able to monitor and control machinery and equipment in real time helps boost your productivity. Introducing smart processes and optimization of processes can save operating costs and improve product quality. And then I think one of the biggest things too, and we've seen this get fed back to us from our customers, is it also gives you an opportunity to identify a greater capacity to innovate. Because you're not spending as much time generating SPC reports or collecting data or dealing with issues, you can actually focus on what's the next project that we're doing to improve, what's the next opportunity we have within our plant to find benefits. We had one customer, they're a food processing customer. They had someone on staff. She had a master's degree in food science. Most of her day was taken up with data collection before we came in and just getting that pulled into reports so she could start doing her job. Now she spends almost all of her time actually applying her food science master's degree to improving product quality and improving processes to make sure that quality is standard across the board, rather than just trying to go get that data. Like I mentioned, I think that Canada is sort of far behind compared to other manufacturing heavy countries right now. But really nobody has carved out too much space. Germany has their Industry 4.0 program. It's a massive collaboration between government, manufacturers, and automation providers. It's where the Industry 4.0 term got coined actually around this program, and it's all about bringing together data on the plant floor, like we were talking about with Industry 4.0, to provide smaller batch sizes, more growth opportunities. They're looking at culminating in 2020 with that, where they're trying to get most of their main manufacturers to be focusing on these. Made in China 2025. China's tired of being a small sort of cheap goods producer for the West. They want to be a leader in quality and management of manufacturing as well. And the date's right in the title with them. 2025 is their target. In North America, we're more looking at people are calling it more industrial Internet of Things, so connecting all the industrial assets to be able to run these type of applications. In this case, really, and I think we have to be focused on this, is that industry is leading the charge and making the changes with government just supporting initiatives, which I think is a very North American thing to do and very exciting. But we do have to step up and be leaders to work to reduce wasted potential in our manufacturing industry. So now we're going to get into the meat of artificial intelligence within that Industry 4.0 space. And first, I want to talk about where artificial intelligence can be effective in your plant, because as I'll intimate later in these slides, really Industry 4.0 and artificial intelligence isn't just a one-stop shop or crystal ball. You do have to understand how to apply it. It's like any other tool. And you have to understand where you can get the most bang for your buck and also be effective within the problems that your plant is already trying to solve. So when I look at different attainable goals with using artificial intelligence within manufacturing, sort of look at three levels. I call it describe, predict, and prescribe. Describe is sort of focused on very similar to what you'd already do with maybe a MES system or a production monitoring system. You're monitoring process variables. The idea with artificial intelligence, though, is that you monitor more process variables and a deeper level in real time than you could with just a human. If you have a human, maybe you have somebody going around and checking gauges every hour to make sure they're within process control limits, or if you're really fancy, you have a centralized SCADA with some alarming when things go outside of different trends. With artificial intelligence, you can be monitoring each process variable that you want to monitor at a very deep level and understand how it's affecting multiple areas of your line. Secondly is predict. I call them catastrophic issues. But really, I don't mean catastrophic like the machine's exploding or something, but something that you aren't expecting to happen from normal operation can be determined from a human's point of view, but things related to large downtime periods or quality issues that are requiring you to either pull back product or rework it, or worst of all, call a recall. And then last would be prescribe. That's sort of the top level. That's either human in the loop or automated process control to tune lines holistically rather than on a station-by-station basis. If you think of sort of the whip crack effect of one operator at the start of the line tuning his process to get it inbounds, but that throws it out of process for an operator down the line who again adjusts and throws off a process for someone even further down the line. Think instead of one overwatching entity being able to make all those adjustments to holistically produce the best product with the least downtime. So with that, now that we sort of have goals in place, I also want to sort of talk about the how and the what. So like, what is artificial intelligence? Because that's a very nebulous term. There's even sort of that sci-fi aspect to it in some ways, right? But really, the terms machine learning, artificial intelligence, or predictive maintenance, they all really are describing the same thing in this sense, which is different collections and sets of algorithms that self-correct or train based on the data that you feed in. So this can be supervised learning, where you're saying, this is a good outcome, this is a bad outcome, tell me how these variables relate to this outcome. That's often the case when you're trying to predict downtime. You know downtime is a bad outcome, good running production is a good outcome. What variables feed into that to show whether you're going to have a good outcome or a bad outcome? Unsupervised learning is more focused on allowing the algorithm to determine what good and bad outcomes are. Sometimes that is more related to quality processes and things like that. Within manufacturing, most artificial intelligence or machine learning applications are focused on pattern recognition. You hear about lots of other artificial intelligence applications like natural language processing, information extraction like search engines. When Google's DeepMind won a game of Go against a top Go player, or winning chess. So these are all different branches of artificial intelligence, but usually in manufacturing, some sort of pattern recognition where we're saying, hey, all these variables or this image or whatever it may be is adding up to telling us that we're going into a state that we've seen before. And that's really nice because for pattern recognition, what you really need is a lot of data. And manufacturing generates a lot of data. When you're making the same part over and over and over, you are often going to be able to have lots and lots of data for both good cases and bad cases. I would be careful though, because what artificial intelligence is it's not a crystal ball that you just put data into and get return on investment out of. There's lots of work that needs to be done, and lots of human knowledge that you have to unlock to be able to have successful projects with it. So it worries me sometimes when I see, and I'm not disparaging any companies in the space, but when you see some of these large companies saying artificial intelligence is this magical thing that's going to solve all your problems, just feed us data to our cloud platform, and we'll get innovation and excitement out for you. So the three main areas that I see artificial intelligence being applied in manufacturing right now are predictive maintenance, like we've talked about, also predictive quality, determining whether a part is going to be a good or a bad part before it even gets off the line. And then finally, machine vision. And I always find this a little bit funny because a lot of plants that I go into already have some sort of machine vision system, whether it's inspection for food processing or a final quality check on metal parts, things like that. And that's a full-on, to me, application of machine learning and artificial intelligence that, so really, most likely you've already taken your first step in using artificial intelligence in your plant. And what we're talking about now is the second step. Now, actually, I'll go back to this though. So what I'm going to talk about now is our approach for doing predictive maintenance. So predictive maintenance is all about identifying downtimes before they occur, and then alerting the right person in the plant to be able to take an action before the downtime actually occurs. And there's varying levels of this. It could be as simple as just letting somebody know that an important process variable is trending out of scope, or it could be that would be sort of that describe level that we were talking about. On the predict level, it could be saying we think this type of downtime is going to occur. That gives additional contextual information for, say, a maintenance manager or a technician to be able to have the right parts on hand or take the right corrective action. And where we're trying to move to is actually integrate that with your maintenance schedule, so we can start to say, we think your machine will wear out on a certain bearing within 20 hours. Your next maintenance schedule for that is 18 hours away. Do you want to try to make it to then, or is that too big a risk for you to take? So I'll talk about a little bit more detail of how we do that now. So what we first do is we uh, collect data for probably at least a month or two. A couple months is our usual. And then we take all your different downtimes that you've had direct from your PLCs and then cluster those using a clustering algorithm to determine um, the type of downtime that we want to predict. Obviously, within your plant or on a certain machine, you have lots of different types of downtime. Some of them are scheduled downtimes like maintenance and service, or just a break for your operators or cleanup after a certain type of product is run. There's also unplanned downtimes, but ones that you really can't do anything about, like you run out of raw material, or maybe you have to top up fluids or lubricants on your machine every certain number of hours or certain number of cycles. But then there's also unexpected, and again, what I call catastrophic downtimes, that are downtimes that don't regularly occur and cause a significant amount of downtime, like say in the order of at least 5 to 10 minutes of downtime, moving up from there. And so we want to be finding those type of downtimes and creating a category for them so we can understand more about the parameters around these type of downtimes and how we can start predicting them. So once we do that and we find the type of downtimes that we're going to try to predict, we look at the machine telemetry patterns leading up to those type of downtime events. So that can be everything from irregularities in production counts to maybe smaller micro stoppages ahead of a larger downtime. It also can be heavily factored from things like temperature, pressure, strain gauges, electrical current draw, pneumatics. And really what we do is we tie into anything in the PLC that we into the programmable logic controller running your production line to be able to view and understand whether that's going to be an issue. And we'll start doing some feature engineering on this to start to identify which telemetry patterns and which variables correspond most closely with your downtimes that are occurring. Once we do that, we can build up a model, and it continues to self-correct once it's deployed into production, but we use those models that we've built to monitor the equipment in real time, and then we'll notify your team before a downtime occurs when a current pattern on a machine is starting to hit the model that we've developed. And that really, in a nutshell, is how we can start to warn you ahead of time downtimes that are going to occur. Sometimes the leading indicators on this, you don't really get a leading indicator until, say, like 5 or 10 minutes beforehand. Sometimes it's in the order of hours or even days beforehand. And that's something that you have to sort of look at with these pieces of equipment. Obviously, the manufacturing that I'm familiar with, there's lots of downtimes at different times on equipment. So sometimes even knowing 5 or 10 minutes ahead of time can be very valuable, say in a stamping operation or an extrusion operation. It allows you to get ready for that and get your machine back up and running as fast as possible. Other types of manufacturing, you want to be trying to get those hours ahead or days ahead predictions. So in terms of some of the different algorithms that get used, there's several. The ones that we find work best, first off, is classifiers. So that's sort of instead of doing traditional statistical process control where you're looking at one variable at a time, you can do multivariate analysis. So you can look at many different variables at a time and understand not just how individual variables correspond to downtime or quality issues, but also how those variables working together and sort of vectoring together turn into issues. Another one that we've had a lot of success with is survival analysis. So this is actually understanding the sort of likely next state, and that starts to give you a dynamic mean time between failure with your pieces of equipment. So you can start to, rather than just saying, okay, our average MTBF last month was 5 hours. Now you can say most likely our next upcoming instance of downtime is going to be 3 hours according to our dynamic MTBF. Or right now it's looking like we're going to keep running indefinitely or something like that until the next shift is done. So that's a very cool one that we're excited about because it really augments one of those traditional manufacturing dynamics of mean time between failure and mean time to repair. And then lastly, we're working a lot more with neural nets, and that's sort of that both that supervised and unsupervised training to start actually giving you recommendations based off of the data of what you should do according to when the next downtime is likely to occur. So hopefully you're excited about some of the applications of artificial intelligence in your factory and are thinking of some plans of where you could potentially put this in. Um, I'm looking at people in this webinar as people who are maybe managing a project with this and are sort of the project champions. So I want to make you aware of the pitfalls of using artificial intelligence in your plant as well. So one of the biggest areas is getting data for this. You need a lot of data to do these type of statistical analyses and run these algorithms. And you need data in real time to get real time predictions. So you're going to have to automate your data collection. This adds a lot of issues. As we all know, there's a lot of challenges with getting data off of the plant floor. There's equipment and controls are often different brands and data schemas, so it's expensive to integrate with your legacy equipment. And then also, I think personally, I've seen a lot of plants being wary of data collection projects because they've had failed one-off projects before, whether it was trying to build something internally or implement a SCADA system where costs got out of control. Once again, a small plug for MAJiK Systems. We implement our data collection with no additional hardware, no PLC reprogramming, and no downtime during installation. We connect natively to all the different controls over your existing Ethernet network in the plant and can get that data for you. You also have to worry about data collection and transfer across plant subnets and DMZs. A lot of plants are implementing these type of network architectures to keep their equipment control systems safe. But then if you're trying to get data out to a computing platform where you can do machine learning and artificial intelligence, it makes it more difficult. And then also just that once you do start collecting this, there's massive amounts of data. For some of our customers, we're collecting more than 20 megabytes per machine per day. And that ends up being a lot when you add it up over a year or over multiple machines in your plant. So you need to be aware of that and how much are you going to keep, how much are you going to use for training, how much are you going to throw out after. Also, I've blown up this diagram from the last page. I think it's very important, especially when you're getting started on these types of predictive maintenance projects. You really need to look at where you want to focus your resources for a pilot and choosing facilities properly. I really like this diagram, even though it's very simple. It's out of a case study from Volkswagen Group about automation in 2007 and how they were looking at finding sort of an optimal level of automation in terms of um, increased automation reduced personnel costs linearly, but then your automation costs, as you start to approach 100% automation, go up exponentially. And I think that still holds very true today, even though the price of automation has dropped considerably. You do need to look at finding facilities in a similar manner to this that have a higher level of automation, but maybe processes that don't need to be fully integrated with artificial intelligence to start seeing the benefits. You want to find something where you can sort of get 80% of the benefits with much less of the spend. So just a few more pitfalls to take a look at. This one first that I have on the list, I think most manufacturers have an inherent sense towards. I hear this quoted all the time on the plant floor of garbage in, garbage out. So if you're providing bad data, you're not going to be successful with your algorithms. And that goes from everything of like you need to make sure that the data is coming directly off of your machines, not through a third-party sensor or collection system, because it won't match up with what's actually going on with your machines. Or also human data always can be adjusted, that type of thing. You also have to have a good strategy around classifying, tagging your data, and also clearing data out once you don't need it anymore. There's also a big decision point at a certain point with these projects of whether you continue to host them on premise or start hosting some of these databases and artificial intelligence algorithms on cloud hosted servers. Often when you get into more advanced artificial intelligence solutions, you need specialized hardware that is available from all the large cloud players, but maybe isn't available as a standard VM or Windows server in your plant. And you want to start looking at that because your machine will change how it runs over time. And as you fix more issues on your machine, that'll also change. And you need to constantly be feeding data back into the models that you're using for predictive maintenance. And the tighter the feedback loop you have on the machine, the better. But you will need to be constantly retraining. We're a Microsoft partner. Microsoft has a really good online machine learning lab that we take advantage of and do this training and redeployment automatically with. A lot of manufacturers still are looking at the cost benefit of cloud hosting though, and want to keep data on premise. So that's a extra sort of area in the project that you need to figure out. I think finally, though, you really want to look at like what are our goals with the project and who's going to use the data and the outcomes and predictions provided by the artificial intelligence algorithms. Doesn't do any good to have it just predicting downtime if it's not actionable by your employees and doesn't get paid attention to. And also you have to have your employees providing feedback on what they need most out of it, right? So it is important to have multiple stakeholders involved. The most successful projects we've had with this were involving everybody from controls engineers and shift supervisors up to IT and plant management, because you can really short circuit a lot of the discovery phase of these projects if you're getting all those experts in the room providing information in. So I want to do a quick case study on a tier 1 stamping plant that we've worked with on a machine learning project. So our work with Magna Carmex, you can find this actually all on the OCE website as well. Ontario Centre of Excellence. So we were able to jointly secure a grant to from OCE to be able to install our data collection software to read telemetry from PLCs on their main stamping lines, and then train predictive analytics models, just like we discussed in the previous section. And what we're doing right now, as we're coming up to the end of the year and the close of this pilot project, is we're providing real-time predictive maintenance recommendations. A lot of our focus is currently on the classification and being able to tell them when different process variables are going out of control limits in real time with a multivariate analysis. And then we're also providing them with predictions based off of what downtime we expect to be upcoming in the range of between sort of 10 minutes and 2 hours. Just to give you some numbers behind that, so we're monitoring now about 100 tags from individual PLCs along their line. 25% of the tags we're pulling data from at 50 millisecond intervals. That has to do with component temperatures, strain, pressures, things like that. Another 25% of the tags we're getting at 100 millisecond intervals. These are additional temperature tags, electrical current, axis positions, and then 50% of tags we're doing at between half a second and 1 second intervals. These are fault codes, alarms, tool numbers, production counters. So we end up processing about 800 measures per second, but then we only persist about 300. That's because we throw out different variables or different readings if there's not enough change from one reading to the next. With that, though, we're still growing the data set by about 1 gigabyte a month. And then with that, though, we have a very low profile on their network. We're doing about 5% server CPU utilization, only adding about 20 kilobytes per second to their network. We've been having some really good initial results from this. We're hoping to sort of get them up to the next level, above 90% equipment utilization, which has been a tough ceiling for them. And that'll help them unlock even more payback from their customers and things like that, because they'll unlock new contract levels. So we're very excited to be finishing off that project and showing some really good results with it. The last thing I wanted to talk about, and again, please contact me directly, or I'll also be sending out the presentation so you can get some links on this. But I want to talk about some of the grants available for these type of applications. Like I said, I feel personally like Canada's lagging behind the rest of the world in terms of our Industry 4.0 and AI implementations. But the Canadian government has also seen that, and they're really stepping up to the plate in terms of what's available. Two of the really big ones are the superclusters that have been announced. There's 5 superclusters with almost $1 billion of funding announced last year. 2 of them are focused around our industries. One is the advanced manufacturing supercluster, focused around Hamilton, Kitchener, Cambridge, Toronto, and is really focusing on many different areas of manufacturing, whether it's more automation, AI, vision systems, that type of thing. And there's projects being announced very soon. All those projects need multiple stakeholders in terms of you need manufacturers involved. You also need technology companies involved. You also need academic institutions and research involved as well. So there's lots of good projects. The best way to figure out where you could maybe fit with these is get in touch with us, because we have some projects that are coming up and running, or also go to the website. I think there's a sign up where you can email people who are running the supercluster to see what projects there are available. Um, Scale AI is another supercluster. It's focused on supply chain and using artificial intelligence to improve supply chain operations. Uh, that obviously supply chain has a huge effect on manufacturers, and I would also and have argued and have a project included that increasing uptime within manufacturers improves supply chain immensely. So predictive maintenance is a huge area for us to be focusing on with supply chain. There's also all kinds of things like warehouse optimization, route planning, all of that as well. Secondly, and this I think is more immediately an opportunity for any manufacturers who are looking on taking their first steps into predictive maintenance, um, is the ASCIP grants. These are the Automotive Supplier Competitiveness Improvement Program grants. They're administered through OCE and also the Auto Parts Manufacturers Association. And you can get grant funding very quickly for initiatives with this. And this isn't just limited to predictive maintenance. If you have other programs, like if you're trying to do more automated tooling or more training even, you can get grants through this program as well. But one of the biggest areas that they're focused on right now, and we've had really good success with, is applying this to predictive maintenance. You can get one-to-one matching on up to $100,000 of funding. That includes everything from for the project, from being able to connect your equipment, data collection, consulting on how to set up your network, all the way up to the actual deployment and running of these type of programs. So lots of good opportunities with that. If you're not in the automotive um, market, but you are a manufacturer, there's also lots of other improvement grants that the government's putting forth. So um, please feel free to get in touch with me if you have certain projects that you're looking to do, but you don't have necessarily a concrete idea of how to get them funded right now. So I think that's about it for what I wanted to cover in this, and we're hitting 12:45 exactly, and I did want to give a little bit of time at the end just to let everybody get on to their next meeting and everything. Um, if you do have, actually, I'll go back to the grants just so you can see those. If you do have questions after this webinar, please feel free to reach out to me. My email is jevans@majik.io. And we'll also be sending the material from this webinar out to you after the webinar. So thanks very much for attending, everyone. I hope you found it useful, and I hope you have some additional knowledge about how you can apply artificial intelligence to your manufacturing operations. And I look forward to connecting with you after. Thanks very much. Bye.